Alright everybody, back again for another one idea video. This time we're going to focus on neutrons for a second. We're going to think about the two things that they do for an atom. So I'm going to click this stable, unstable down here, and I'm going to open up the mass number thing. So we talked about how the protons determine what an element is. Neutrons determine whether an atom is going to be stable or unstable. And they also affect the mass number. So the mass number is protons and neutrons, right? So if I've got one proton and one neutron, my mass is 2. You'll notice this is still a stable atom of hydrogen. I can add another one, and now it's an unstable atom of hydrogen with a mass number of 3. So I'm just going to keep adding protons and neutrons and think about this. So I've got lithium now. Lithium is unstable with a mass number of 5. If I add another neutron, it becomes stable with a mass number of 6. I can add another one, and it is still stable with a mass number of 7. So there are multiple versions of an atom that can be stable. For some atoms, not all. Some atoms only have one version that's stable, and some atoms have no versions that are stable. But that is determined by the number of neutrons and protons and their ratio of being together. Remember, protons plus neutrons equals mass, and then the number of neutrons and protons helps you figure out the stability of the atom. One other thing I might... Well, no, I'm not going to do that right now. So that's what I want you to focus on, thinking about neutrons. We can play around with this a little more. I'm going to add until I get to carbon. And so carbon right now has a mass number of 10 because I've got 1, 2, 3, 4, 5, 6 protons and 1, 2, 3, 4 neutrons. In general, I need to have at least the same number of neutrons for smaller elements to be stable. Also, having more neutrons is a good thing too. So that's one thing I really want to point out. A lot of things that I saw at the beginning is people thought that you needed to always have the same number of protons and neutrons, and that's not true. You often need more neutrons than protons. If I have something even bigger, like, let's go, fluorine. So fluorine, I've got 9 protons. I'm going to get it so I have 9 neutrons. It's got the same number, but it's still unstable. So fluorine with a mass number of 18, that's 9 protons and 9 neutrons, is unstable. So I have to add one more neutron for it to be stable. That's about all I've got right there. I'm going to leave it at a short little 3-minute video and move on to our next video in a second.